Well, hi there, it's Mr. Doro. Today we're going to be talking about limiting reactants. We're going to be expanding our knowledge of stoichiometry to figure out what the limiting reactant is and how much of each product would actually be formed in a reaction. Well, to figure out what a limiting reactant is, I've got some pictures for you to look at here. And if you look at the first picture up on the left, about the brownies, we have our reactants. We have 2 brownie mixes and 12 eggs. Now we don't need all those eggs. We can make those 2 brownie mixes, and each one needed 2 eggs each, and we have 8 eggs left over. We're going to have some things that are left over, and we're going to have some things that limit the amount that we can make. We could only make 2 batches of brownies because we had 2 brownie mixes. If you look at the hamburgers over here, you have 3 hamburger patties, 4 buns, and 5 slices of cheese, and however many tomato slices there. Well, to make a burger, we need to have 1 bun, we need to have 1 patty, a slice of cheese, and 2 slices of tomato. So we can make 3 full burgers because we're limited by the number of burger patties that we have. And that's the only complete burgers we can make is just 3. We're going to have some leftovers though. We're going to have a bun left over and a tomato and some pieces of cheese in case you wanted a cheese and tomato sandwich. And so the limiting reactant in this case was the burgers. The excess reactant was everything else that we had. If we look down here at this reaction, we have hydrogen, H2s, those are these, and then we have N2s, those are the bigger ones right there, and then at the end we made NH3, which is ammonia. And you can see before the reaction happened, we had these all react together, these react, and these react to make those. I got them circled on this side, but we had some leftovers. The leftovers were the N2s. Those are the excess reactants. Now these are some terms that we need to know. And we need to be able to identify that the leftover ones here are the excess reactants. Some terms that you need to know are LR, that means limiting reactant. That's the one you run out of. Limiting, I can't fit the G, there we go, reactant. And then another one is XS, which means the excess reactant. EXCESS, reactant. And that's the one that you're going to have extra of. Something you always have to remember, the limiting reactant has to be a reactant. So it has to be on the left side of the arrow. And it is the thing that limits the amount of products that we can make. Well, there are 3 very important things that you need to know. Make sure you memorize, because these are things you'll need to know on quizzes and tests, what the limiting reactant does. First of all, it stops the reaction. When you run out of the limiting reactant, the reaction stops because you ran out of something. It determines the amount of product formed. Just like on the burgers, we only had 3 patties, so we could only make 3 full burgers. So that determines the amount that you can make. And if you were to add some more back to it, it would restart the reaction. You add it back, the reaction starts to go again until it runs out of either that thing again or something else. Well, in order to find the limiting reactant, we're going to have to use stoichiometry. Usually you're going to be given a starting mass of each reactant and then find out the mass of the products. So I really wouldn't write all these down, but if you just listen to them, there's a couple little tricks that you need to know here. So first of all, step 1, properly balanced equation. Make sure you have that. Do a mass-to-mass action line from one of the reactants to one of the products. So you're given the mass of each reactant, go to one of the products. Now here's the tricky part though, step 3. Complete another mass-to-mass action line from the other reactant, the other mass that you're given, to the same product that you did before. So 2 action lines, both going to the same product. Then you can compare the results of them, and whichever one made the least amount of product that started with the limiting reactant. That was the limiting reactant, the one that made the least amount of product. The other reactant is the excess, and then you do another action line with the limiting reactant to determine the mass of the other product. Alright, so here is a limiting reactant problem that we're going to go through the steps that we just did. 30 grams of sodium chloride. So we start out with 30 grams of this stuff, 30.0 grams, and are allowed to react with 20.0 grams of this. Now that doesn't mean that they all react. One of them may run out before the other one does. How many grams of each product would be formed? So here's what we need to do. We need to do an action line starting with 30 grams of NaCl. And then we're going to pick a product to go to. I'm just going to pick this one right here. And so when we do that, we do grams of NaCl to moles of NaCl. 1 mole is, I believe it's 58.44 grams. And then we continue on. moles of NaCl to moles of, now I'm going to switch over here to Na, get this from my balanced equation, 2 moles of Na for every 2 moles of NaCl, and then my final step, I'm going to go right to grams here. You could find out the limiting reactant by not doing this step, but we're going to have to get to grams anyway, so might as well do it. Moles of Na to grams of Na, this is 22.99, that's a 2, and then 1 mole. And when I do that, all that math, I end up with 11.8 grams of Na. What that means is if all of this 30 grams right here reacted, then I could produce up to 11.8 grams of Na. So now I'm going to do another action line, and I'm going to start with my 20 grams. I got to find out what if 20 grams of, that's a 20.0 grams of Ca reacted. Sorry about the messiness here. So I'm going to change my grams of Ca to moles of Ca. 1 mole is 40.08 grams of Ca. And then I'm going to go from moles of Ca to moles of, watch this, I'm going to the same product I did before, the same one. Moles of Na. This is a 2-to-1 ratio. I'm trying to find out how much Na I can make if all 20 grams of that Ca reacted. And then I go 1 mole of Na to grams of Na, which is 22.99 grams of Na, and I calculate all that out. And when I do that, I find out that that could make 22.9 grams of Na. Now I got to look at my answers. What my answers are saying are, if all 30 grams of this reacted, I could make up to 11.8 grams of this. If all 20 grams of this reacted, I can make up to 22.9 grams of this. So you see, once I make my 11.8 grams, I'm going to be out of NaCl, and this reaction is going to stop. That makes NaCl my limiting reactant. So here's what I do. Whichever one was the biggest one, I cross that right out because that doesn't count. I can't make 22.9 grams. After I make 11.8, I'm out of NaCl. That makes my limiting reactant, my Lr, I like to label it right on there, is NaCl, not Na. A lot of students think that, oh, then that's my limiting reactant. These were both Na, and that's not even a reactant. That's a product. Sorry I get excited sometimes about that, but my limiting reactant is whichever one I started with that made the least amount. So one more step then. I know how much Na I'm going to make. That's 11.8 grams. Now I got to find out how much CaCl2 I'm going to make. I need to start my action line with my limiting reactant, which is 30.0 grams of NaCl. And now everything's going to look the same until I get to this step right here. I'm going to change it, instead of Na, I'm going to change it to CaCl2. I'll show you. All right, so there's my action line all set up, just like, and by the way, if you're having trouble with the action lines, maybe you need to go back and check out the stoichiometry videos, the mass-to-mass action lines. And so my answer that I get is 28.5 grams of CaCl2. And that is my answer because, and this is my other answer, I don't have to redo that one, and that is because the NaCl is going to run out. Now, many people are going to look at this and they're going to say, oh, this has got to be the limiting reactant because it's got only 20 grams. No, you have to do these 2 steps to determine the limiting reactant. By the way, I do like you to write what the excess is also. That's the other reactant, Ca. Okay? There's one other thing that the limiting reactant can tell you too. It can tell you how much of the other reactant, the excess reactant, that you're going to use, and then you can find out how much you'd have left over. That may be useful sometimes. So since we know the limiting reactant, I'm going to start with 30.0 grams of NaCl. That's my limiting reactant, same one we used on the last slide. And then I'm going to change that to moles. 58.44 grams of NaCl is 1 mole of NaCl. And then after that, I'm going to change my moles of NaCl. I'm going to switch over here now to moles of the other reactant, the excess reactant, which is Ca. And using my mole to mole ratio from the balanced equation, 2 moles of that for every 1 mole of this. And then I can find out 1 mole of Ca is 40.08 grams of Ca. And I can figure out how much Ca I had to use in order to use up my 30 grams of NaCl. Now it should be a number lower than 20, otherwise I did something wrong somewhere, because if it's higher than 20, then Ca would have been my limiting reactant. And so when I plug this all in, I get 10.3 grams of Ca used. It only took 10.3 grams of Ca to use up this 30 grams of NaCl. And that's why we don't do a gram to gram ratio, it's a mole to mole ratio. And so we go back here, we can figure out how much was left over. We started with 20 grams of Ca. So if we have 20 grams and then we subtract the 10.3 grams that we had at the beginning, we find out that we have 9.7 grams of Ca remaining. Should be left over at the end. And that could be useful to use. Okay, so now it's your turn to try it. I've given you a balanced equation, so that's all set and ready to go. You're going to start out with 25 grams of each reactant. So 25 grams, 25.0 grams of this, 25.0 grams of this. You need to determine the limiting reactant. Remember, you need to start with this and go to one of the products, either one you want to, and then start another action line with this and go to that same product, see which one made the least amount. If you need to, go back and watch that long slide that I went through all of them. You're going to need 3 action lines for sure. I want you to determine the limiting reactant. That takes 2 action lines, and then the mass of each product. Your limiting reactant, when you calculate that, that should tell you what one of the mass of the products are, and then a third one would work. Here's the answers I got, so you see if you get those too. And here's one more for you. This one you got to do a little extra work because you got to balance the equation. And I've given you, starting out with 20 grams of propane, 20.0 grams of this, and 30.0 grams of oxygen. Pick one of the products, go to them twice, figure out what the limiting and excess reactants are, and then determine the answers for how much product can be made. There's my answers, so you check those out too. Have fun.